Everyone knows of the flat earth theory, science deniers thinking that what they observe is the true physical reality. Today, we are going to look into the mathematics of different geometries to come up with the true theory of the Earth's shape. What does flat Earth geometry look like? We are all taught in high school algebra the Pythagorean theorem, x squared plus y squared equals r squared. This gives us the formula for measuring distances between 2 points. We can extend this to form a coordinate system that solely depends on the hypotenuse of this triangle and the angle it forms with the horizontal axis. R is the radial distance from your origin, and phi is the angle from a self-defined phi equals 0 line. Using this coordinate system is a more natural way of describing position relative to a local origin rather than a position relative to a global origin. There's another way to represent this called a metric. Metrics just tell us how to measure distances on different geometries. The flat plane metric is given by ds squared equals dr squared plus r squared d phi squared. In this notation, we see how infinitesimal changes in the radial or angular directions give rise to a small change in the total distance s. If Earth were flat, we would use this metric to measure distances along its surface. As expected, with this metric, we find that traveling a total radial distance r means that we only measure a total distance of r. Traveling the circumference of a circle with radius r0 gives us a total distance of 2 pi times r0, which is the circumference of a circle. Let us consider a sphere now. Spheres are defined in terms of the radius capital R, the angle from the vertical theta, and the angle from the horizontal phi. We can modify the 2D polar coordinates slightly to get 3D spherical polar coordinates. Assuming we are only on the sphere's surface, this gives rise to the spherical metric ds squared equals r squared d theta squared plus r squared sine squared theta d phi squared. However, those who live on the flat Earth would not know that this theta coordinate existed. The most natural coordinates to work with for them would be the r coordinate and phi coordinate in the flat plane. If we are walking straight in the radial direction, the spherical metric tells us that the total distance traveled will be r times theta, which we can then define as lowercase r corresponding to the r in our flat plane coordinate system. Now, through the magic of calculus, we can rewrite our spherical metric as a spherical flat metric, which is just the spherical metric in terms of r and phi. There's a big difference between this and a flat plane metric. We see that if we were to walk around in a circle with constant radius r0, the distance we measured would not be the 2 times pi times r0 we expect from the flat plane, but instead it would be 2 pi r times sine of r over capital R. This is the number one way a mathematician who thinks they are living on a flat plane could convince themselves they are indeed on a sphere. However, there is a third geometry, one that surpasses even the spherical Earth theory and trumps the feeble minds of the flat earthers. Toroidal Earth theory. Toroids are defined in terms of their average radius a, cross-sectional radius b, horizontal angle phi, and cross-sectional angle epsilon. After modifying the 3D spherical polar coordinates to create 3D toroidal polar coordinates, we produce the toroidal metric ds squared is equal to b squared d epsilon squared plus a plus b cosine epsilon quantity squared d phi squared. Now, flat earthers would not understand what this epsilon coordinate is, so we must define the 2D r coordinate this time as epsilon times b in order to get the toroidal flat metric. Once again, measuring the circumference will produce a different result from both the flat plane and the sphere. The question is there a case where the toroidal Earth agrees with the spherical Earth? The answer is yes. It turns out that in all the niche cases of the sphere, namely the poles and the equator, we can find points on the toroid that align with common sense. The North Pole corresponds to a specific circumference on the toroid with the South Pole 180 degrees opposite of it, and the equator corresponds to the inner and outer radii of the toroid with epsilon equals 0 or pi. All other cases have paths that loop around the toroid's surface until they travel the full distance. This means that there is only one conclusion that we can come to. The Earth is not flat. The Earth is not a sphere. The Earth is a donut.